when you're talking about grades, okay? So that's a couple of different things about it. What we're going to do is we're going to calculate some simple interest. Now remember, simple interest is really easy to calculate because it stays the same every year. When you have the principal, the interest rate stays the same every year. Now how we calculate simple interest is simply by looking at this formula. L equals the amount of interest, P is the principal, R is the annual interest rate, and P is the time in years. So when you are working with something that says simple interest, this is what you need to be using. You need to probably, write this down somewhere, or if you can remember it, awesome. But this is very, very important. So let's go ahead and do a couple of problems here. I'm going to go ahead and see time. We're good in time. So let's give you 2 minutes on the clock. I just want you to work on this by yourself at, wherever you're at. Just kind of write it on a scratch sheet of paper, and don't put anything in the chat box, and then we'll go over it together and see where you stand. So I'm going to put 2 minutes up on the clock. Go ahead and get started. Go, go, go. When you are finished, go ahead and give me a green check. When you are finished, give me a green check. One minute up on the clock. Almost. All right, let's go ahead and look at this particular problem. Again, super easy, simple interest, one of those things that you just kind of have to be aware of. I'm going to go ahead and put our formula up there. L equals PRT. How much interest would you earn in each year? So we're going to take the principal, which again, we're working, in this particular TGA, we're working with bigger numbers, longer years. That's the only difference. So it's just a little more math that you have to look at. So our bigger number is 13,500. I'm going to multiply it by my interest rate, which is a 0.09. Again, I have to change it into a decimal point. And then I'm going to go ahead and multiply it by 1. When I do that, 13,500 times 0.09, I get $1,215, okay? So that would be my interest rate after 1 year. Now, what would my balance be? So then I would just simply take 13,500 plus $1,215. I would then add that together, plus 13,500 equals $14,715. So that would be my balance after 1 year. So 14,715. After 7 years, what would my account balance be? Well, I could take my interest rate of $12,000 or $1,215. I could multiply it by 7 because it does not change. And so when I multiply it by 7, I get an interest of $8,505. Then I go ahead and I add 13,500 plus 8,505, and I get $22,005. Okay, that would be my balance after 7 years, $22,005. Now, after 15 years, what would the account balance be? I would do the same thing. Take 1215 times 15. I just had to stop for a minute there. I didn't know what I was doing. 1215 times 15 would equal 18,225. Taking 18,225 and adding it to the principal, 2,225, I would get $31,725. Okay, that would be my balance after 15 years. How many people had any questions about how I did this one? Any questions? No? All right. Pretty straightforward. You're just working with bigger numbers. By the way, I do want to see your work. I saw a lot of people who, there was a handful of us that did not show our work on our TGA and lost a lot of points just for not showing their work. So please make sure that you are showing your work just like this. Here's a perfect example of what your work should look like, okay? So please make sure you're showing your work. All right, let's look at this one. I'm going to go ahead and kind of go through this very quickly. I want to make sure will we see this on the TGA? Yes, Maylin, you will see something similar. Question 1 and 2 have to do with simple interest. Again, bigger numbers and longer years. That's the only difference. So you're just going to work with bigger numbers. That's it, okay? So how much interest would you earn in 1 year? Again, I always like to put at the very top my formula, so it's always reminded in my head where it's at. So with that being said, I'm going to go ahead and say L equals, and I'm going to go ahead and put my principal of 25,148 and times my interest rate at 0.06, again putting it into a decimal, taking it out of the percentage and putting it into a decimal, and then we're doing this for 1 year because we just want to find out for the 1 year. So I'm going to do 25,148 times 0.06 times 1 would be $1,508.88. Okay. Now I'm going to go ahead and find my balance. I'm going to take 25,148 plus 1,508.88, and what was it? 25,148. I would get $26,656.88. Okay. So here is my interest, 1,508.88. Here is my balance after 1 year, 26,000. Oops. Let's make sure it's right. $26,656.88. What would my balance be after 6 years? Well, I go ahead and do a couple of different things. I take my interest and I multiply it by 6. Okay. When I take my interest of 1,508.88, 1,508.88, and I multiply it by 6, I get $9,053.28. Now once I find that out, I can now add it to my principal, $25,148, and add $9,053.28. I should get plus 25,148, $34,201.28. That would be my balance after 6 years. Not bad, huh? That's pretty good. 34,201.28. All right, what would the balance be after 25 years? Again, doing the same thing, taking my interest, 508.88, and I'm going to multiply it by 25, and what do I get? I get a whole whopping $37,722. Okay. Now I'm going to go ahead and take my principal and add it to my principal at 25,148 plus 37,722, and I get $62,870. That's what my balance would be after 6 years. 62870. How many of you have any questions about this? If you understand what I just did, go ahead and give me a black bat emoji. Give me a black bat emoji. If you understand what I just did. Excellent, excellent. Not too difficult. It's just bigger numbers, okay? Just bigger numbers. Just watch your numbers. All right. Now we're going to jump into compound interest. So compound interest is interest that is added to the principal of an account. But as it's added, the interest you're receiving starts generating more its own interest. So it's like interest on interest, taking like bricks and building off of one brick, building and building and building and building, okay? So what happens is that your account starts exponentially growing. As it grows, it speeds up the value of the account, okay? So as you get a bigger principal because of the compound interest, the more interest starts building faster, okay? So in some ways, having compound interest is better than simple interest because you can make more money with compound interest. Here is an example. You put $1,000 into a savings account with 4% compound interest. With that, you can make $40 on your interest. That would be your interest. So your balance after a year would be $1,040. Now, if you would calculate it again, I'm going to calculate it by using this, by using 1,040. So when I calculate it again, I'm going to have $1,041.60. Okay? So I'm earning more money. I'm not calculating it from the original principal balance. I'm calculating it with the interest. So with that being said, compound interest can be both a good thing and a bad thing. Obviously, there's frequency to it. You have three options. You can find it, it can compound in a daily, it can compound monthly, or it can compound quarterly. The more you have in the account, the more that it will compound a lot faster, okay? Now, what did I say just before that there's a positive and a negative. The positive is if you're an account holder and you're having a compound interest account, that's great because you're earning more money on your money. But if you are a borrower, that means you're taking money from the bank and you have a compound interest loan, then you are paying more interest. So you have to be very aware that when you do take a loan, that you are not paying compound interest. Because if you are, then what you want to do is you want to pay that principal off faster. Because the lower the principal, the slower the compound interest will gain. The higher the principal, the faster the compound interest will gain. Okay? With that being said, how do I calculate it? Well, there is that rule of 72. Now, the rule of 72 doesn't give us an exact amount or doesn't give us an exact time frame. What it does, it just gives us an approximate, which is not bad. I mean, hey, you can, at least you'll know, but it gives us an approximate. So what the rule of 72 says is that when you calculate it, the number of years required to double the principal, is based on the annual compound interest rate. So what that means is that you divide 72 by the interest rate. When you divide 72 by the interest rate, do not, I can't type right now, do not put it into a decimal. Okay? Do not put it into a decimal. For example, an account has 8% annual compound interest rate. So what I would do is I would divide 72 by 8, which would give me 9. That 9 is going to say it will take 9 years for that money in that account to double. Okay? So the rule of 72. Let's put it into practice. I'm going to go ahead and go over the first one with you. Okay? Now this is where it's going to get a little hairy. So make sure that you are paying attention. Make sure that when I'm finished, take a photo, do what you need to do with your phone, or take a photo with your phone, do what you need to do because it's this is where it's going to get a little hairy, so just pay attention. First of all, we need to know what our interest rate is, and our interest rate is 6%, so it's right there. And we need to know that our principal balance is $12,000. So with that being, with knowing that, I'm going to go ahead and do the rule of 72. So 72 divided by 6. I didn't convert it. I didn't do anything. I just took 72 divided by 6. So when I do, how many times does 72 go in, or 6 go into 72? Who can tell me? How many times does 6 go into 72? 12 times. Good. So this one is just telling me, simply just saying, it is going to take 12 years. 12 years to double, okay? So it's going to take 12 years to double $12,000. So what is doubling $12,000? How much would that be? Good. It'd be $24,000. Okay, we kind of have to, 12 times 2 is 24. Excellent. Okay, so my balance would be, after 12 years, would be $24,000. Okay, now that's pretty easy. And if you get 1 and 2, you're in good shape, because these are the numbers that you are going to work with when you are working with 3 and 4. Okay. So those numbers right here are what you're going to work with for 3 and 4. So now 3 and 4 is asking me, how many years will it take to double again? Well, how many years did it take to double the first time? It took 12. So if I was going to double it again, how many years is it going to be? 12 times what? Yeah, 12 times 2, okay? One double is 12. The second double is going to be 12. So add those up, what do I get? 24. So it's going to take 24 years to double again. Okay? Now the second part of the question is, what is its balance? So if it takes 1/12 to make $24,000, and down here I did another 12, so what would 24,000 times 2, because I'm doubling it again, would equal $48,000. Okay, so here is my answer. Does everybody know where I got this from? Give me a green check if you understand this so far. Give me a red X if you don't understand it. Oh. 3 of us understand? $48 is the answer for the last one, because on number 3, there's 2 questions. How many years will it take to double again? And this one, it says balance, question mark, meaning what is the balance then? All right. Now, what will the balance be in 72 years? How I figure this one out is, I go ahead and put 72, and I'm going to divide it by 12. How many 12s? How many groups of 12 will go into 72? Each group is going to equal $24,000. So how many groups of 12 will go into 72? Good, 6. So 6 groups of 12 will go into 72. Now, once I know that, then I can go ahead and I can multiply $24,000 by 6. When I do that, 24 times 6, I'm going to get $144,000. After 72 years, I will have $144,000. Here is another kind of picture to show you. If I drew a box, okay, I drew a box. I have 72 here. This box, this whole box represents 72 years. And if I said each column here is 12 years. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so now I have 12, 12, 12, 12, 12, and 12. Each one of these 12s is 24,000, right? 24K. You see where I'm getting this 24,000 times 6? Does that make sense? Okay, good. That's how you do this compound interest. Let's go to the next problem. This one's a little more tricky, especially when it gets down to 3 and 4. Well, 3 is just like what we just did. 4 is kind of a little more tricky. Because of time purposes, I'm going to go ahead and go through this with you. And then if you have any questions, stop me as we go. When will a savings account double in value if the current balance is $30,000 with an annual compound interest rate of 9%? Number 1 is our rule of 72. So I'm going to go ahead and do 72 over 9. When I do 72 over 9, I get 8. So it's going to take me 8 years to double my money. When I double my money, after 8 years, what will I get? I'll get $60,000. How I figured that out, I just went 30,000, which is my original principal, times it by 2 because I'm doubling my money, and I get 60,000. That's my answer. Okay? This right here is the most important information, these two things, okay? Nothing else I need to know. I just need to know that information for right now. So number 3 is saying, what will my balance be in 24 years? Just like right here, I need to take 24. Oops. I'm going to take 24, and I'm going to divide it by 8, right? Because I want to know how many groups of 8 are going into 24. I know there are going to be 3 groups of 8, just like my chart says. So if I if I drew a chart here, where is it? There it is. If I drew a chart and I said this whole box equals 24, and I divided it up, 1, 2, 3, and each one of these equals 8, 8, and 8, and each one equals 60, then I'm going to go ahead and I'm going to 60 times 3 equals what? $180,000. Okay? We're good so far, right? Because each one of these right here, each 8 equals $60,000. Number 4, how many years will it take for the account to have a balance of $150,000? This one's kind of a little tricky. Remember, this is the one in the red box is my most important information. If I'm working with balance, I'm going to keep working with balance. So I need to know how many doubles are in 150. So I'm going to go ahead and divide $150,000 divided by 60. Oops, $60,000. From doing that, I'm going to find out how many groups of doubles. Okay? When I do that, I will get 2.5. That's how many groups. So if I was to look at my chart here, I would say, oops, I kind of moved my chart. I would say 1 here, 1 here, and then half of an 8 right here. Okay? 2.5. So if I do 2.5, well, what's 8 times half of 8 would be? So I'm going to go ahead and I'm going to multiply 8 times 2.5. When I do that, I'm going to get 20. So how many years will it take to have a balance of 150,000? 20 years. Questions? No questions? All right. Do we understand compound interest. This is, and I'm going to tell you there's no trick. This is exactly the format for your questions on your TGA. There's no difference. Now, thinking about it though, which is better? Which would you get paid more out of? Simple or compound interest? Good, Malin. Which one would you get paid more money? Simple or compound interest? Ooh. You would actually get paid more money out of compound interest, right? Because what I just said before, compound interest starts building. If we go back to what compound interest is, it starts building interest and generates its own interest from the interest you receive. So interest you received, it starts to generate its own interest. So really when you get paid, or when you look at it and you're asking ourselves, when do you get paid more, simple or compound? It's going to be compound interest because, again, compound, you're building upon that interest on interest, okay? So when you get those big higher numbers, it's just going to keep generating faster and faster. So compound interest would probably be your best bet when you're talking about which pays more, okay? All right. Let me kind of go over how to turn in your TGA. I apologize for going through this super fast. Unfortunately, I only had you for one day with your TGA. So with that being said, this is how you go ahead and turn in your TGA, just in case you forgot, is you go to your tools section and you go to assignments. You click on assignments, and when you get in there, you're going to actually click on the blue 5.012 TGA graded assignment right there. Do not click on the 5.011 TGA, because if you submit it in there, I will not grade it and I will just delete it, okay? Oh, I will give you that number of the week, David. Don't worry, class is not over yet. I still have 4 minutes with you. So when you do that, go ahead and click on that. When you get in there, you'll see this submission submittal section here. You're going to add your file, and you're going to add it, your document, your Word document file. And then you're going to add maybe a little note, I don't know if you want to. And then when you're finished there, you're going to click submit. You are now turned in your second TGA. We only have 1 more to go, so that would be it. Again, I'm probably going to be starting to grade these over the weekend for sure, because you've had all day yesterday or tomorrow to work on this. So there should be really no excuse why you couldn't get this in, but please make sure that you get it in by the end of tomorrow at 4, okay? Anybody have any questions about anything that we saw today, about any calculations? Some of us are giving